Try this one. All right, so number 4. Let's try this one. All right, so last time, today's a big word problem day. Is that what you were hoping today? When you woke up this morning, did you think word problems today in math class?
All the time.
Oh, okay, good. Thank you. Please do lie to me. I appreciate it. All right, 7.4, 7.5, word problems. Today's a big word problem day. So this is a money one. Remember, on the money word problem, it's a money one, or value. They call it value. Value or money, same thing. Basically, what do? You have one equation that has no money, and the second equation that's all about money. That's how you always do the money ones. So one equation that's no money, and the second equation that's all about money. That's what we always do on these. It's almost kind of off the screen a little bit, huh? All right, so now what are the two things? They're always talking about two things, huh? What are the two things we're talking about in this problem? Tickets. Yeah, two different kinds of tickets, huh? The general admission and the upper reserved. So G and U maybe would be nice. So general admission and upper whatever. So you can use X and Y if you want to, but I think it's easier just to use meaningful letters. So G and U, general and upper. Now, we'll have one equation like that, and then the one below it, we'll put the money in there, huh? Do you know what I mean? Like, how much is the general tickets? $6.50. So I'll put $6.50 and the upper is $8? $8 for the upper. Do you see that? Does that make sense so far? So the first equation, that no money, right? Just G and U. The second equation, you put the money next to the G and next to the U. The second one has the money. This is a G here. Okay. And then go ahead and put in there's a 407 and a 277-150 are the other two numbers. You know where those should go. The money one has to go on the money line. The second one has to go on the second line. Remember that? So this one's the 407. This one's the 277-150, like that. Good. Okay, so now, so there's our two equations. It makes sense. We always do money ones like this. Again, the first equation is just the letters without the money. Second one, you put the money next to the letters. And the money on the other side too. All right, so now, how do we solve those two equations? Yeah, remember you want to make those front numbers be opposites? Remember how that's always the plan? Make those front numbers be opposites, right? So what are we going to do for this G up here to make it the opposite of 6.50 G?
Negative 6.50.
Minus 6.50, yeah. That making sense? Getting comfortable with that, I hope? Yeah, I'm gonna take that top equation and go minus 6.50, minus 6.50. I'm going to multiply all three of them by minus 6.50, because that'll make those front things opposite, the front G's opposites, right? So use your calculator. Those are the big ugly numbers. What's that number on the right?
Yeah, that's right.
Yeah, but I mean, what are these multiplied to be? Negative something. What is it?
2645.5.
I'm sorry, what was that?
2645.5.
2645.5. Get rid of that 4 there, huh? 2645.5?
Yeah.
Good, thank you. Guys getting that? Getting those numbers okay? See what I did there? I just multiplied through 2645.5. Let me write that again. So I just multiplied through that top equation by minus 6.50. Good. And then the bottom equation, no change. Just bring it down. And then add them up.
If you put this one first and then the second, you say okay. You could say add. Oh. 126.
We good? Just making sense? Getting the hang of solving these? So then the G's cancel. What is this? 1.5. Just use your calculator. These are all big, ugly numbers. Don't want to show up to the next exam without a calculator. This will be painful. That one. I can't do that one. What is it? 126? Thank you. 126 like that. Yeah, then divide. Yeah. Everybody good to there? Is that making sense to there? I'm going to kind of run out of room here. I'll bring it up here. So I have 1.5u is 126. Divide by the 1.5. And the u equals, I don't know. What is it? 84. Thank you. So u is 84. That's the, what are they called? The upper seats, 84. Okay. Now, how do we get the other one? Yeah, you can. Yeah, the easiest way is just to subtract from 407 because 407 is the total amount of tickets. You know what I mean? There's two kinds of tickets, total 407. So once you have one of the answers, you could just subtract from 407. Does that make good sense? Right? Or if it bugs you, you could just do what we've always done, which is just plug into the top equation. It's going to be the same effect. If you just take this top equation and you just plug in the 84, you'll get G, here I'll just rewrite it. G plus U is 4, am I on the screen? Barely. Plug in the 84, so G plus 84 is 407. Subtract 84. G is some 323. So 323 general admission and 84 upper. Is that good? So questions, so money problems. So there's going to be one money problem, in the exam, a couple weeks. So always the first equation is just no money, just regular letters. The second equation, you put the money next to the letters. The money over here too. And then make the fronts opposites. Get them to cancel. Get your first answer. Plug in, get your other answer. All right, so that's money problems. There's one other question. And we might have travel also, I'm not sure. So here's a mixture. We're mixing like soybean meal is 14% protein, cornmeal 7% protein. How many pounds of each should be mixed together to get 280 pounds? It's 12% protein. So it's kind of like chemistry or something like that, where you're mixing things together to make what you're trying to make. All right, so how's this going to work? I'm gonna just put some buckets or beakers, like chemistry lab. That's what pretty much every math teacher does. I think it's about the best way. It's the only way I know of. It's pretty nice, I think. Percentage on the bottom. Percentages are going to be along the bottoms of the buckets or the beakers. And on the top will go the amounts. Okay, so I'll just put the 3 percentages on the bottom. So 14%, 7%, and what's the other one? 12. 12%. Good so far? Just taking the 3 buckets, the 3 beakers, like chemistry beakers, chem lab, and putting the percentages on the bottom. And then the amounts are going to go on the top. Now they're only giving me, there's only one other number in the problem. You know, I've used the 14, I've used the 7, I've used the 12%. What's the only other number I haven't used? 280. And what does it say about the 280? Look, it tells you where it goes. 280 of the 12%. So the 280 goes over the 12%, huh? Make sense? And that's how it's always going to be in this, in the word problems we do in here. Next semester, take Math 103, they'll move that number around on you a little bit more, be a little more complex. But for the mixture problems we do here in Math 201, that number always goes on the right side. So what goes up here and up here, I got to put something. I got to put the amounts. And I don't have any other numbers, so guess what's going to go up there? X and Y. Yeah, that's where my X and my Y go. It's in those 2 spots. Okay. So now that's my picture. I need to start writing equations from that picture. We have 2 letters, huh? X and Y. Remember how it works? If you just have 1 letter, you only need 1 equation. But if you have 2 letters, you need 2 equations. So since I have 2 letters, X and Y, somehow I need to find 2 equations. Just like the last one, the money one. See how we had 2 letters, G and U? So we had to have 2 equations, huh? So whenever you have 2 letters, you need 2 equations. The quiz one we did at the start of today, yeah, there it is, the quiz one, that only had 1 letter, X, huh? I mean, at first it was L and W, but I made them both into X, huh? So really we only had 1 letter when it was time to solve, so we only needed 1 equation. See how that works? So, all right, so when you have 2 letters, here X and Y, you know we're going to need 2 equations. How do we get them? Well, the first equation is right across. You just take the tops, just like skimming off the top right there. X plus Y is 280. Good so far? It's right across the top. And the second equation comes from multiplying top and bottom. Multiplying top and bottom. So what do I mean by that? I mean 14 times X. By the way, you might wonder, Mr. Heron, shouldn't we change that to 0.14? Actually, we can just leave it. I'll explain later. But for now, just to make things easy, let's just leave it as a regular 14. It'll actually work that way, and I'll give the details of why later. Multiply top and bottom here, 7y, and top and bottom here, 12 times 280.
So you don't have to multiply it as a percentage?
Right, and I'll explain that. Let me get to the details later. But right, you're totally right. For now, yeah, just leave it as a normal 14. Yeah, you don't make it a 0.14 or a 0.07 or a 0.12. Just make it normal. It'll work. Is that good so far? Does everybody see what I did for that second equation? I just multiplied top and bottom, top and bottom, top and bottom on that second equation. Top and bottom, top and bottom, top and bottom. Okay. Oh, and can somebody have a calculator? What is 12 times 280? 3360. 3360? Thank you. 3360. Okay, 3360. Good, there. So again, the first equation is just top, top, top. Second equation is multiply top and bottom, multiply top and bottom, multiply top and bottom. So now we're in the same place we were on the money problem. We have 2 equations. You know what to do, right? Make the front numbers opposites and then solve. So what am I going to do to make this and this fronts become opposites? Yeah, I'm going to do minus 14 on the top one. Does that make sense? So now it's just like the money one. Now just go minus 14, minus 14, minus 14 across the top equation there, because I want to make those fronts opposites. And I'll get minus 14x minus 14y, and I have no idea what 280 times minus 14 is. 3,220? 3,920? Thank you. It's negative, huh? Because it's a positive times a negative. Let's see where we're at there. And then the second one, you just write it down like we always do. Everybody good to there? And then we add them up. The x's cancel. Minus 7y and
Negative 560.
560, thank you. Okay, we good? So I'm going to kind of running out of room again. These are long and messy. Maybe bring it up here if I have room over here. Minus 7y is minus 560. I'm a little bit off the screen, huh? Okay, and then divide by the minus 7. Is that 80? Positive 80. So y is positive 80. So we've got y is positive 80. And that's y. Now, can we get x? Yeah, again, the subtraction thing would be the easiest. See that first equation? They add up to 280. So just if you have one of them, if they total 280, and you have one of them is 80, what's the other one have to be? 200. Just subtract that. But if that bugs you, go ahead and just plug in. Just plug in right there. So you get x plus y is 280. Plug in right there. I'll do it formally, but yeah, if you notice that, you can save some time. 280, subtract the 80. X is 200. So there we go. We solved the mixture problem. Now, they're going to ask me over here, they're going to say, how many, what's the first part? How many pounds of, cornmeal? They're saying cornmeal here. Well, how do you know which of these is cornmeal? That's why I should have used more meaningful letters instead of X and Y. If I used C for cornmeal and S for soybean would have been easier, but we can still figure it out. Yeah, because the cornmeal is, what percentage is the cornmeal?
7%.
Yeah, the cornmeal is the 7%, huh? So the 7%, I put Y there. So it's the Y, which is the 80. So the 80, yeah. So you got to kind of do some tracking if you just use X and Y instead of meaningful letters. So that'll be 80, then they'll ask you for the other one, which will be the 200. So that's how much you should mix of those different parts to make the mixture you want. So there it is. So you'll be ready for chemistry. If you're going to go on and take chemistry. Questions on that one? You going to go on and take chemistry?
I'm taking Chem 101 right now.
Oh, the prep class.
It is not this easy.
It's not this easy?
Oh, no.
It's even messier, huh?
Oh, no.
Okay. Get ready for 3A next semester, right?
No. I don't have to take. I'm bypassing 3A.
Okay. All right. So let's try. All right. So there it is. 1 canned juice drink, 50% orange juice. Now there's 10. How many liters of each should be mixed to get 5 liters of 14% orange juice? All right. See if you can do the same thing. The 3 beakers, the percentages.
Why do you only teach you
put it 15 and 10.
I'm thinking about just sitting in here and like not even asking permission to be in this class. I'm just gonna be here.
So I'll put 46. That should be 40%.
It should equal 14%. Yeah, that's 14%. Oh, because it is 5 liters, that is 14%.
Yeah, and you do 4 liters. It's not fair. Why are you?
14?
So I like all is
7. You gotta multiply these two. No, it is like that.
Yeah, man.
Yeah, it is like that. It's triple.
So 10x plus 15y equals what?
70.
It just benefits me more. To narrow it down to 1 is just like.
We just times negative 10, right?
Well, I'm doing 15. Okay, so I have 1. What you get?
10 times 14.
40. I think I did that shit wrong.
Oh, that's
What'd you get?
no, put the plus, right?
No.
And plus 7?
all right, are we good with the beaker thing?
You got X on it.
Okay, so
You got X or 1?
so what do we got? 15. The percentages go on the bottom. 15%, 10%, 14%, like that. Okay, and then and the 5 liters goes up here, right? The other two are X and Y, or if you want to use meaningful letters, what is it? I don't even know what we'd use. I'm just going to use X and Y. Yeah, if you use an O album, I think it's a 0 probably. I don't know. Do whatever you want. You know, whatever works for you. So any kind of letters up there. So is that good to there? Is that making sense? It's going to be this way every time for the mixture. It's always, you know, X and Y or whatever letters you want there, and the right side's the numbers. Okay, now how do we, 2 letters, got to have 2 equations. First one is right across the tops, right? Right across the tops. Equation 1, tops, so that's X plus Y, 5. The second equation comes from multiplying top and bottom, doesn't it? So multiply 15X, multiply 10Y, multiply 5 times 14. What's that, 70? 70, yeah. 70. Oh, by the way, let me explain now why you can ignore the decimal thing. Because I'm saying you can skip the decimal thing. Why is that okay? Well, because really if I did the decimal, it would be 0.15, it would be 0.10. Here, let me go back before I clean this one up. It'd be it'd be 0.14, wouldn't it? It'd be 0.14 times the 5, right? If I did the decimals, it would be like that, right? Well, do you realize I could get rid of them as soon as they showed up by just multiplying both sides by 100? Since it's on both sides of the equal sign. Now, careful. If the decimals are only on one side, the mixture will always be on both sides. So I'm saying for mixture, it's always safe. Just get rid of the decimals. It'll always be okay. But some other word problems you do sometimes, it's not okay to get rid of the decimals. When? When they're only on one side. If the decimals are only on one side, then you can't get rid of them. But if they're on the left side of the equals and the right side of the equals, then you can just multiply. Remember, with an equation, we can always do the same thing to both sides, right? So just, you can multiply by 100, right? I could just go, I'm not going to do all this. I'm just going to skip the whole thing, really. But I'm just saying I could, I could multiply both sides by 100. That moved decimal 2 places, 2 places, 2 places. So I might as well just skip the whole thing. That's why it's okay. But again, it's not okay if they're just on one side. All right, so for mixture, it's always okay. Skip the decimals. So we got 15x, 10y, 5 times 14, which is 70. Okay, you know the deal now. We need to make the fronts be opposites. So I'm going to multiply by negative 15, negative 15, negative 15. And we get negative 15x minus 15y minus 75. And the bottom one is 15x plus 10y is 70. Add them up. These cancel. Minus 5y. This is minus 5. Good to there. Bring it up here maybe. Minus 5y is minus 5 on the screen. Yeah. Divided by minus 5. Y is just positive 1. So we got y. How do we get x now? You can just subtract from 5, right? This equation says x plus y total 5. So if one of them's 1, the other's 4. Or if you want to be more formal, you could plug it in. So I could say, all right, I'll plug in x plus y is 5. Plug it in. X plus 1 is 5. Subtract 1. X is 4. So there we go. So 4 is the amount of 15%. 1 is the amount of 10% to mix to get what you need.
The order, it doesn't matter, right?
Well, they're going to ask you, particularly, like they're right now saying, how much 15%?
Oh.
So how much 15? That'd be the 4, Yeah, so they just look at what they're asking, make sure you're giving them what they're asking for. So the order does technically matter. Good on that? We good with mixture? Questions I can answer on that one? So we've had two kinds now, right? Money and mixture. Is the differences making sense? So money, you have the top equation which has no money, no money, no money, and the bottom which has all the money. And mixture, you have the beaters, right? A little different. Okay. Okay, so here's another money word problem. Clearly, parking meter contains dimes and nickels, 275, 41 coins, how many of each? So it's a money problem. So give that a try. Set up your, you know what to do, right? 2 equations. Always 2 equations. First one has no money in it. The second one is all about the money. And what are the 2 things we're talking about in this case? It's not tickets. It's not like general tickets and upper tickets or something. What is it? Dimes and nickels. How about we use D and N? Dimes and nickels. Dimes and nickels. So remember the first equation, no money. Just the, see if you can get it. Let me give you a minute. Dimes plus nickels, right? No money at all. And the bottom, when you put the money, now what is the money, the monetary worth of a dime? 0.10D, What about a nickel? 0.0, it's 0.05, right? We can't do 0.5 is 0.05, right? I see that mistake a lot. Watch out. Be careful. It's 0.05, right? For a nickel. Not 0.5. 0.5 would be 50 cents. Like that, we good? And then, what else do we got to put? We have 2 other numbers, 275 and 41.
41 goes at the top.
Yeah, 41's in the top. The money's always in the bottom, Does that make sense there? See how that's how money always go? The top one has no money. The bottom one has all the money next to the letter, right? Now, one difference, by the way, here's a mistake I see a lot of students make. They'll go, for the bottom one, they'll go 41 times 2.75. That's not right. That's what we do for mixture. Do you see that difference? It's easy to get those confused. For mixture, we multiply. but we don't for money, right? $2.75 is the total money. It's not saying $2.75 41 times, is it? It's just saying total $2.75, that's all, right? No need to multiply like we do for mixture. All right, can you take it from there? Can you solve? You know what to do, right? Make those fronts opposites. Make those fronts opposites.
There you go.
And when it says I got 30 plus
27.
okay, when I put X and Y would equal 25. Okay.
Yeah, please, yeah, right. That doesn't have percentage. Correct.
Okay, I was getting the wrong number, but I think I did.
And so this one would be, no, you got a multiply. I would draw the beakers. I think the beakers would help.
Well, it's just setting up the equation. I haven't done the second part yet. So that would be 30, 30x, 5y equals 20%.
Remember I said for the beakers, you have to multiply. That's why we saw the Can you remember this one? Because for the mixture, you got to multiply.
Oh, yeah, okay, that's where I did the wrong. Okay.
Okay, so that top equation, we multiply through by what? Minus 0.10? Minus 0.10, minus 0.10, right? To make the fronts opposites? I guess we could have just got rid of the decimals on the bottom one too if you wanted, but we got a calculator. It's not a big deal. Have a few decimals. What's that? Minus 4.1? And then the bottom one. And then add them up. Those cancel. What's that? Minus 0.05 and minus 1 point. Is it 1.35?
Yeah.
Like that. We good to there? You guys getting that okay? And then divide by minus 0.05. So what do we got? We've got n equals,
27.
is that what it is? 27? Thank you. 27 nickels. 27 nickels. How many coins in all? 41 coins in all, right? So I can just come up and subtract, huh? Right, so we have n is 27 nickels, and then 41 minus, so what's that, 14 dimes? And we're done. Is that good? Question? Which one? Oh, you got a different number, you mean? Right here. So, dimes are 5 cents? Or I'm sorry, nickels. 5 cents?
I think like what page is it?
It's a wrap.
Which one was it? The first one?
Oh, I think
Why did you watch it on there?
I should about stand.
I don't want to waste your time. Yeah.
All right, we good? Other questions on that one? We good? All right. Okay, let's take a look here. So, the store makes or mixes Brazilian coffee, $12, $15, blah, blah, blah. Now, here's the question. Is this one has money in it, and it talks about mixing, kind of both, huh? That's what's kind of a little bit confusing about this one, right? There's money, clearly. So you might think at first, oh, it's a money problem. I got to do the money thing, where I make the first equation have no money and the second one have all money. But no, actually, it's a mixture. It's just mixing money things of monetary value. How do I know it's mixture? Simply they say it. That's the rule. If they say mixture, it is a mixture, bottom line. So what does that mean? That means I'm actually going to do the beaker thing. Because it's really, even though money is involved, in the end, it's really a mixture problem. You're mixing together different kinds of coffees. Okay, well now, what's a little weird is there's no percentages, huh? We're used to seeing percentages on these mixture problems. Instead of percentage on the bottom, because we don't really have any percentage, what am I going to put on the bottom? The money. That's where the money goes. Yeah, the money is like the percentage. The money's like the quality of the kind of coffee, you know? It's like percentage.
It's $50 per kilogram.
Yeah, exactly. Yeah, it even says per. So, you know, the per word's like in the percent.
The percentage is like 17% of 1
Mm-hmm. Yeah, it's the same exact thing. So the money per kilogram is just like a percent. Exactly right. Yeah, per is a good word to key on. Percent per kilogram.
No.
Same idea.
For this to be chemistry, it would be $12 per kilogram and then $7.50 per microgram.
They make it more.
How many moles per microgram?
All right. So let's. So we put those down there. So the money is like the percentages, right? And then what other number do we have? 252. Like that. Same thing then, right? X and Y. Or I guess you can call them Brazilian. Maybe that'd be easier. And Turkish. Brazilian and Turkish. See, that's the same thing in the end. The money's just doing the percentage. So take it from there, solve it from there. So the first equation is just right across the top.
You gotta get the ball first.
Second equation is multiplying the top and the bottom, right? 12 times B. There's that call I was expecting. 13 times 252.
That's my alarm. Every time I hear that, I'm like, I just.
That's your favorite sound.
Wave of panic goes over my.
All right, everybody good with that? We good with the
You got it right away.
way we're handling the equations? Multiply top and bottom, top and bottom, top and bottom. James, I think all the young people in here are kidding you about technology. That's my whole life. My kids, almost every day, there's some joke about dad and technology. I'll be like, I'm like, Daniel, what's this phone doing? Dad, you just do the da-da-da-da-da. I'm like, what? I don't know what. How do you know we're not manuals? You just know it. You know, I don't know. I broke through this stuff.
Step on this shit.
You are not that
Oh, I'm sneaking up on 50 here. So these young kids are born with technology.
We're still not that much different than
All right. So is this good? So first equation, top, top, top. Second one, multiply, multiply, multiply. Right? We good? And then you got to make the fronts be opposites. Minus 12, minus 12, minus 12. Right through the top. Like that, right? Make the fronts opposites. It's getting old hat, just easy. You're used to it now. I'm hoping you could do this without too much trouble. 12 times 252. Somebody got that number? 3276 negative, thank you. 3276. And what's 13 times 252? It's got to be bigger. 3024? 3000 what? Well, is the other number wrong then? Okay, I think these are reversed. Okay, so in other words, this one should be the 3276, is that right? And the top one is the 3024 negative? Like that? Okay, thanks. All right, so there we go. These cancel. What's that? 3t equals 252. Bring it up here. 3t. 252 still on the screen, divided by 3. So 84. T is 84. They total 252. So subtract from 252, right? And I can't do it. 168. Now must be the B, the Brazilian coffee. So that's how much Brazilian coffee, Turkish coffee you mix to get the thing to happen. So I just want to show you another mixture. I think we'll be done with these now. One more mixture, but it actually has money in it, but it's really still a mixture. I mean, just do it. The money just plays the role of the percentages. Just goes in the bottom like that. Any questions on the money and the mixture? Is that all good? All right. Gene. Okay. So this is motion problems. Truck and car leave a service station at the same time, travel in the same direction. Truck travels 48 miles an hour, the car 42. Yeah, did we do some of these before? Have we done travel before? Okay. Yeah, so it's the dirt, distance is rate times time. It's exactly right. We're doing that again. Distance equals rate times time. So whenever you have travel, motion, use this equation. Remember, we have the 6 boxes down below, 2 boxes underneath each letter. 2 boxes under D, 2 boxes under R, 2 of them under T. 2 distances, 2 rates, 2 times. We're talking about a truck and a car. Truck and a car, so truck and a car. All right. The truck travels 48. So remember how it's going to work now. Remember what we have to do. First step is to get 4 boxes. We want to get 4 boxes somehow. Now, let's just take the numbers as they come. 48 miles per hour. Is that a distance, a rate, or a time? And that's a rate. That's a speed. Miles per hour is a speed or a rate. Rate means speed, right? This is speed. So 48 miles per hour. Now, is that the speed for the truck or the speed for the car? Yeah, that's the truck is 48. So that goes in the truck R box. Does everybody see that? See how I'm lining up, the R with the truck? 48 miles an hour there. Okay, and the car, 42 miles an hour. So that's the rate for the car. Good so far? Now, next, what's the next number they give me? 12 miles. 12 miles. Is that a distance, a rate, or a time? Now, miles is distance, huh? 12 miles. So now, does that go here? Or does that go here? Is it going both?
They're leaving at the same time.
So this is where we've got to get real. We've got to get real about what's happening with the truck and the car. Let's back up. What is going on with this truck and this car? They're leaving a service station at the same time, and they travel in the what? Same direction. But the truck's faster. So it's going to, right, do you understand? So they leave, they go in the same direction, but the truck is faster. So what's going to happen as time goes on? The gap between them is going to grow and grow and grow because the truck is always going faster, right? So the gap is going to get wider and wider and wider and wider. And they're asking, they can maintain radio contact as long as they're within 12 miles. So when will they lose contact? When will the gap between them be more than 12 miles? Because as soon as it is, no more radio contact. Make sense what they're asking? So that distance, that 12 miles, that's how far between them. That's not how far the truck went, nor is it how far the car went. It's how far between them, isn't it? So it can't go in either one of those T boxes. Even though it is a distance, it's not the car's distance nor the truck's distance. It's the distance between them. Does everybody see that? It's kind of confusing. In fact, what you could do is you could put it down here. Might be helpful. But you can't put it in the D box, in the truck box or the car box. Does everybody see why? Again, it's not how far the truck went. That's not what they're saying. They're not saying the truck went 12 miles. No, that's not what they're saying. They're not saying the car went 12 miles. If they did, I could put it in those boxes. But that's not what they're saying. 12 miles is the gap between them, right? It's not how far either vehicle went. Okay, well then what are we going to do? We need 4 boxes. That 12 didn't really help us out much. I need something in these boxes. Or these boxes. What can I do? Well, same time. What can I do with same time? Whatever goes here and goes here must be the same. Right? But I don't know what goes there. They don't tell me the time. Right, so call it X. But it's X in both places. That's what we do. Does that make sense? They're the same, so they're the same letter. It's not X and Y. They're X and X. They're the same letter because they said the times are the same. But I don't know what the times are. So use a variable. Use an unknown. Use X. Does that make sense? They're both X. So now I've got my 4 boxes. That's the first step. Step 2. Get the front 2 boxes by multiplying. What am I talking about? Notice what this equation says. Distance equals rate times time. Distance is rate times time. So that means this box is rate times time. Isn't it? So that means what goes in this D box here? 48x. And what goes in this D box here? 42x. See how that's working? Because that's what the dirt thing above says. That's what it says, huh? It says distance equals rate times time. So if you have the rate and the time, you times them to get the distance, huh? And the rate and the time, you times them to get the distance. Okay, so that's step 2. Step 3, remove the front 2 boxes on the screen and write an equation. So those front 2 boxes now, here's my equation is going to involve the 48x, the 42x, and the 12. Now, here's something to help. If it's same direction, if they give you a problem involving same direction, subtract. If they give you opposite directions, add. So are these 2, the car and the truck, are they going in the same direction or the opposite direction? Same, right? They come out, go the same way, even though one of them, truck's going faster. So that means I'm going to take 48x and 42x, and I'm going to what? Same direction, subtract to equal 12. If they were going opposite directions, I would add to equal 12. Does that make sense there? Now that's not really logic. That's just my little trick to help you get through the homework problems. I don't like that, though. I like logic. Let me show you logically why that's true. Because if you think about it, one car's here, the truck, let's say the truck, and here's the car, okay? And between them there's a gap, right? Here's the gap between them. And we want that gap to be 12 miles. Isn't that what they're talking about? The truck goes faster, gets ahead, you want the gap between them to be 12 miles. So do you see how the truck's distance subtract the car's distance? How far is the truck? What's the truck's distance? 48x. What's the car's distance? 42x. See how 48x take away, 48x take away 42x is the 12? See how the bigger line minus the smaller line is the difference between them, the 12? The gap. That's why this equation is true, logically. Does that make sense? Bigger distance minus smaller distance is the difference, is the gap, is the 12. All right, this is easy to solve. Only one letter. Just x, no y. So we only need one equation. We don't need two, huh? So that's the one part that's good about these. There's just one equation. So that's what? 6x is 12? Right? 48 minus 42? How do you finish solving for x? Divided by 6. X is 2. X is 2. Now careful though. Careful. Remember in a word problem, the answer may or may not be the x. The x is the key. You take that key and you go unlock whatever door they do want. You can unlock anything. You have the key to answer any question. Now, what is their question? Here it is. There's only one question mark up there. It's all periods and one question mark. Where's the question mark? Right there. Here's the question mark. When will they lose contact? When? When is a what? A distance, a rate, or a time kind of thing? I go when. That means time. That means time. They want to know time. So take your x equals 2, come up to the time boxes, and it's just x. So the answer is just 2. Nothing more fancy going on there. It's just 2. But they could have asked, how far will the truck have gone when they lose contact? If so, I would have plugged the 2 in to the distance for the truck. 48 times 2, 96, would have been the answer. So they could have asked many things at the end. Does that make sense? So you got to always check with what they're asking for at the very end. Questions on that one? Travel. All right, let's try another one. One kind of like we just did, but they're not going to give it to me. All right, so here we go. Number 2. Listen, they're kind of doing half the boxes for you. Yeah. See if you can fill in the missing boxes. I just want you to fill in those 4 boxes. Train leaves the station, travels north, 50 kilometers an hour. 2 hours later, second train leaves on a parallel track, travels north, 90 kilometers an hour. How far from the something that's off the screen will they meet? How from the station will they meet? The word that's off the screen is station. How far from the station will they meet? How far from the station will they meet? All right, dirt. See, there's the dirt. Distance, rate, time. Distance, remember, distance equals rate times time. We don't normally put this part over here. If it bugs you at first, just ignore it. Just ignore it if it's bugging you. We don't normally put it up like that. They're setting it up a little different. I'll come back to it. Just ignore it. Distance, rate, time. Right? Can we fill in this box here, the fast train rate box?
We need a battery.
What's the fast train rate? 90. They're handing us that. 90. Yeah, right. Good to there so far? All right. Now, how do you know what goes here? What goes in that first D box? Yeah, I don't know. It's kind of weird the way they put a D here. Maybe. I don't know what they want. In fact, maybe they do want D.
They don't give it.
So let me see, because they want a D, which is dumb. I don't like the way they're setting it up. So yeah, they want you just to put D there. D for dumb. Anyway, so they just want you to put D. Remember, I told you a better way to do it is I said, just multiply these things and put it here. Multiply these and put it here. That's what it says. D is R times D. But they're doing the multiply at the back. They're just doing it at the back is what they're doing. It's just a weird way for them to do it. Sorry if this is confusing you. They're just putting it at the back. So what goes at the back? The equation D equals 50 times T plus 2. D equals 90 times T. They just want you to put the 50 and the 90 there. That's all they're doing. Do you see that? So let's just finish this thing up. So we know what we do, right? We just...
There's two parts to this.
Yeah, I know. It's because they gave a different setup. Don't worry about this one. I'm not going to put it like this on the exam. But just copy down what I'm doing right here. So this is just D. And then they want you to put, here's the equation, the 50 and the 90. And then notice what it says. How far from the station will they meet? Will they meet? If two objects, well, that's not a good way to say that. Let me say it. If one catches up to the other, if one catches up to the other, at that moment, their distances are equal. Right? Isn't that what it means? If one thing takes off ahead of the other, and the other one is faster and starts catching up, boom. The moment of catching up, at that second, they have the same distance on. When you catch up with somebody, you've run the same distances now. They're going to throw that at you a couple times in these remaining, but they're going to go da-da-da, starts out first, and the other one catches up. As soon as you read that catch, you go, oh, equal distances. That's what catching up means. One of them's distance equals the other. Distances are equal. That means this distance formula must equal that distance formula. Now, I wish they'd put them over here. All they're doing is instead of putting them over here, they're putting the distance over there. That's all they're doing. Is that confusing for you guys? They're just moving the distances over to the right side instead of putting them under the D box where they belong. They're just sticking them over there on the right. See, really, the way I showed you to do it is I would put these distances over here. Anyway, I'm tired of this problem. Let's wrap up this question. So it's going to be 50, because I don't like trying to work with their system. They're forcing me to do it their way. So they want me just to set those distance boxes equal, you see. Because that's what it means to catch up with somebody, is the distances are equal. So there's my little equation. So there's what you fill in. Just copy them down. Distribute 50t plus 100 is 90t. Right, I just distributed. How do you solve for t? Yeah, remember when you have the letter on both sides, you get rid of one of them, so subtract 50t from both sides. Gonzo. So we get 100 equal 40t. Is that good? 90 minus 50 is 40t. Divide by 40. What is that, 2.5?
Yeah.
Time is 2.5. That's what they want. That's the answer. 2.5, what is it, hours? Yeah, hours. How do we know hours? Right here. Kilometers per hour. The time unit is hours. 2.5 hours. The faster train will catch up with the slower. All right, enough with that. I'm not going to give you one like that. I'm doing what I said not to do. I'm saying, careful, always read the question. I was tired of the question, though. So, yeah, it says how far. Right. How far? So, James is right. It says how far. So, I've got to use this as the key to unlock Which box? What's the how far? If I say how far, am I talking distance, rate, or time? Distance. So you go, so the how far, normally it's right there, but they've moved everything over to here. So you plug into either one of those boxes. Plug what? T equals 2.5. That's the key. Plug it into either one. They're going to be equal. Remember? They're equal. They're the same. They're going to come the same. So I'm going to do the second box. That looks easier. 90T. Plug in T is 2.5. So that's 180 and half. 225? Is that what it is? 225 miles. So that's how far, or kilometers, I guess it is in this one. That's how far, whatever. It's 225. 225 is how far the faster train went in catching up. All right, I'm done with this one. All right. It takes a passenger train 5 hours less time than it takes a freight train to make the trip from Picture Rock to Rockville. Passenger train averages 58, freight train 29. Find the distance. All right, so travel, distance equals rate times time. We have what? We have freight, and a passenger. Freight and passenger. All right, so give it a try. Remember what you got to do. Step one, you've got to get 4 boxes, right? So get 4 boxes from the words.
So less times.
So what do we do with this 5 hours less time? What do we always do in any word problem when they go 5 less, 5 smaller, 5 shorter?
Subtract.
X minus 5. Totally. And some other box will be just X every time. See how that's so consistent in word problems? Whenever they go blah, 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 3 longer, X plus 3. 3 shorter, X minus 3. So 5 less is X minus 5. Where, though? Where does that go? Passenger train. Oh, I put the passenger on the bottom. So the X minus 5 will have to go there. That's the time, isn't it? That's time. And the other one's X. Does that make sense on that? All right. And then what else do we have? The passenger is 58 kilometers. That's the rate, huh? And the freight is 29. That's his rate, his speed. We good with all that? Making sense? I probably should have put the passenger on the top. I just didn't notice that word at first. Doesn't matter. All right, so we have the 4 boxes. So you get the 4 boxes. And then step 2, how do you get the front 2 boxes? Distance equals rate times time, huh? I get the front 2 boxes by multiplying, right? You guys with me? So this box, so 29 times X and 58 times X minus 5. I'll distribute it in a minute. You can distribute now. Doesn't really matter. Making sense what I just did there? Distance equals rate times time. Rate times time. Rate times time. Good. And then, step 3, front 2 boxes, remove, write equation. Remember, it's the front 2 boxes that make the equation. What do you think? So I'm going to take the 29x. I'm going to take the 58x minus 5. I'm going to write some kind of equation. Am I going to add them or subtract them to equal what number? Let me ask this. Are there any other numbers in the problem that I haven't already used? Are there any other numbers I could even put over here? Are there any other numbers up there? No, I've used every number. There's no other number to put here. There's no other number. So what does that mean? When no other number, just make them equal. When there's no other number, am I making sense? Let me go back. Remember the first problem with the truck and the car, right? There was that 12 that was nowhere in my table, that I had not used in my table. Remember the 12? There was another number that I hadn't used in my table. So that's what they equaled, right? They subtracted, because they were same direction, to equal the 12. Remember that? So if there's some other number that you haven't used yet, then yeah, that's what they're going to add or subtract to equal. But in this one, there's no other number. I've used all the numbers. There's no other number like, the total trip was 12 miles or the da-da-da-da. I've used all the numbers. There's no other number. So what? That means they're just equal. Just solve that equation. Does that make sense? So if there's some other number, you're going to add them or subtract them to equal that number. But if there's no other number, they're just equal. Now that's not logic. That's just, I'm giving you a trick to help. Why logically, real life? When I say logic, I mean real life. Why real life would those be equal? They are distances, remember? They're under the D. Why would the distance the freight train goes be the same, equal, to the distance the passenger train goes?
If they have the same destination.
Yeah, we're talking about the same trip. Just doing it faster or slower. Right? It's the trip from wherever to wherever. Picture Rock to Rockville. We're not talking about a different trip for the two trains. We're just talking about one doing that trip faster than the other. So the distances are equal, of course. That's the logical reason. Of course the distance boxes are equal. It's the same trip, right? Same starting and ending points, right? All right. Distribute. 58x minus, what's that, 250 and 40, 290? How do you solve for x here? I'm going to subtract the 58x, be a little quicker, just get the x on the left side. What's that, minus 29x, I think? Yeah, equals minus 290. Last step, divide by minus 29. X is 10. But that might be the answer, it might not. That's the key. Take that key and unlock the right door. What door? What door do they want unlocked? Find the, and also here it says how far, see up there, how far, is that a distance, rate, or time question? Distance, they want distance. So I take this key and I plug into one of the distance boxes. It doesn't matter which one, remember they're equal. It'll come out the same with either box. Plug into the distance box, 29x, plug it in. 29 times 10, 290 is the final answer. That's the distance, 290. 290 kilometers is that distance of that trip. All right, that was a lot of work. These travel ones are a lot of work, aren't they? Is that making sense? Let me run over it one more time. So they gave me they said 5 less, that's x minus 5, the other one's x. They gave me the two rates. You get the 4 boxes on the right, you multiply to get the distance, because distance equals rate times time. So you multiply, then you grab those out and you set them equal because there's no other numbers. If there's no other numbers, you just set those 2 boxes equal. If there was some other number, I would add them or subtract them to equal that other number. And I solved. And I got the key was 10. They wanted how far. I took that key and I unlocked how far. Distance. 290. All right. These take practice. They did for me when I was a student. There we go. So try that one. We have 5 children. Never thought I would have a lot of kids. Had one, and we had another one. Anyway, so we have 5 kids, and by the time you get to your 5th kid, you feel like you know what you're doing. Like, I got this figured out. I know how this works. Our fifth little girl, she's now 10, Abigail. She rocked our world. She was different than the other 4 children. We lost her 3 times running away. I lost her for like periods of time. Like, where is Abby? I don't know. She was just more brazen, just more willing to do crazy things than the other 4 ever were. So yeah, I lost her 3 times. Once at the beach, Pismo Beach. We lost her, and it was a crowded holiday weekend, and my wife took one daughter and went off to the bathroom, and I had a couple of the other kids, and I didn't know I had Abby. I thought Abby had gone with her. And Abby was like 2, like a toddler, you know. And my wife comes back from the long trip to the bathroom, at the beach where you walk far off to the bathroom and you come back. And she comes back and she's like, "Where's Abby?" I'm like, "What do you mean, where's Abby? I thought Abby was with you." And then you have that shock feeling, We all look around, there's just people everywhere at Pismo Beach, and we're like, where in the world is Abby? And then there she was, about 100 yards, just toddling down the beach, just walking. And we lost her at the park, and we lost her out of our front door of our house for about, it was like 2 or 3 or 4 hours. She was gone. The policeman thought I was on drugs when he recovered her. That was the funniest one. I came home from work. It was like 8 years ago when she was like 2. I came home from work, and my wife, as soon as I got home, she left to go shopping. She was waiting for me to get home. So I got home in the afternoon, like 3 or something, because of my cush job here at the junior college. I get home about 3, and my wife hears I'm home, and so she takes off to go shopping. As soon as she leaves, I think, oh, where's Abby? Abby's probably upstairs taking a nap. So I go upstairs, and I open her door, and I look in, no Abby. So then I start looking around the various rooms of the house. I go in the backyard. I'm like, I call up my wife, who's headed down to the grocery store at this point, on the phone, like, "Where's Abby?" She's like, "Abby's upstairs taking a nap." I'm like, "No, she's not." And she's like, "You don't know, and I'm like, "You didn't see Abby?" So my wife turns the car around. So the other 4 kids are there, and I go, "Kids, we've lost Abby." Again. I'm like, "Let's go." So we go out the front door, and I say, "Daniel and Emma, you go that way." We go out our street, our front door of our little suburban house. And I go, "You 2 go down that way. You 2 go down that way." And as I come out the front door, it doesn't occur to me. I noticed that on one end of my little suburban street is a police car. And on the other end of the suburban street is a motorcycle cop. And they're never on my street. I'm like, that's funny that the police are here on my street when I'm having kind of an emergency. It didn't occur to me that they were there and had been there for hours because of my emergency, right? And so I'm out the front. They'd been driving up and down the street trying to find me, because Abby had walked off when my daughters had opened the door to talk to some neighbor friends. Abby had snuck out the door. Other kids were afraid to do this. And she was 2 years old, and she just toddled on down the street, crossed a fairly busy street, she's crazy, to some other neighbors, and this lady had found her and said, "Who's your mom?" And she couldn't even talk, and so they called the police, and the police had been driving up and down our street with Abby saying, "Which one's your house, honey?" And Abby's just looking at the houses, so we go out there, and I go, that way, kids." And just like 1 minute later, Emma comes running back up, "Dad, they've got Abby." And I look, and there's the officer, and there's this neighbor lady I'd never met before carrying Abby, and they come up, and Abby goes, "Dad." So then the officer knows it's me and hands me. But that lady looked at me like I was the scum of the earth. Like I was just the delinquent. And the officer, he was really serious, I was like, "Oh, thank you, sir. Oh, that's great. Thank you so much." And he's like, "Can I come in your house, sir?" He was like, totally. I'm like, "Sure, yeah." So we start headed to the house, and he's like total deadpan, like he's going to lock me up, And we opened the front door, literally. I just opened the front door. He took like 1 step inside. I think he was expecting it to be like craziness. Yeah. He took 1 step in, and he's like, "Oh, it's no problem. Yeah, this happened to me." And he's like a totally different guy. My parents lost me, and he's a super nice guy then, And I think he thought it was going to be like a drug house, and just all craziness, Anyway, there's my lose your toddler. I guess so. That's his experience. What's that?
That guy meet the Millers, the real thief, that guy that's trying to smuggle drugs across Mexico.
I didn't see that. That's what he thought, I guess, until he saw the house, I guess. Anyway. All right. So try the toddler. Try the toddler problem. So distance, rate, time.
So was she fearless?
She's always been that way. She has. She's a very good soccer player today because she is gutsy. She just goes for it. Distance, rate, time.
Such type of rap. You got a yellow too.
You know where he's at.
You want to get the yellow? from already. The rest are they want Juventus to win, so Real Madrid can take a step forward to the final.
Or is the referee playing him?
And you can't hear these guys are.
Next season, Monaco versus Real Madrid.
But if it's Monaco.
Oh, right. But you can't figure it out, huh? Yes.
Real Madrid.
And it's just a little thing too.
So 4 boxes.
That is the funniest math problem I've ever seen.
Yes. You know what? I bet she had this problem.
Atletico and Juventus.
I've been lost. I got lost quite a few times when I was a child. Yes, I did. And I remember, I was probably like maybe 1.5, 2. And
That's
I
it
remember
already.
this. I do. I remember it vividly. And like, I got lost at the beach, I got lost in the mall, I got lost.
Are you sure you're not?
I'm surprised.
I was told.
All right. So toddler takes off running down the sidewalk 250, and then there's the mom, right? So we have the toddler and the mom. Okay. So the 250 feet per minute, is that a distance, a rate, or a time?
That's a rate.
That's a speed, huh? That's like miles per hour, except it's feet per minute. It's a rate, huh? It's a speed, it's a rate. That's how fast the toddler goes. So that's the rate for the toddler. Does that make sense? 1 minute later. Now, 1 minute, that's a number. 1 is a number, right? 1 minute later, that's a time fact, isn't it? That's going to do something in a time box, huh? Does that make sense?
1 minute later, they're headed in the same direction.
If you leave 1 minute later, your time of travel is 1 minute less, right? Because you started later, you traveled for less
And that
time.
means the toddler has traveled 250 feet in that
So-
1 minute.
So that's the mom's time, x minus 1. Does that make sense? And the toddler must be x. Is that making sense? Because the mom leaves 1 minute later. She has 1 minute less, because she's going to have to go faster. She has less travel time, right? 1 minute less.
Instead of shower, so it's like-
And then the 780, that's the rate for the mom, right? She's faster. All right, so we got our 4 boxes. So you're getting the hang of this time thing, but just like the last one, what was the last? The train, one of the trains went, I can't remember. Faster? Or left later? Oh, left later? What was it? Left 5 hours later or something? What did it say? Same kind of thing. It was 5 hours less time. Yeah, so the last one said 5 hours less time. So that was x minus 5 in the time box, right? This one says the mom leaves 1 hour later, same thing, or 1 minute later. So x minus 1. Gone. All right, so we got our 4 boxes. What do you do once you have the 4 boxes? What's step 2? First step 1's get 4 boxes. Step 2, how do you get the front? 2 boxes. You multiply, huh? Distance is rate times time. You multiply. Right, like it says up here. Distance equals rate times time. Yeah, so it's 250x, 780, x minus 1. That good? And then we grab, the step 3 is always remove the front 2 boxes, write some kind of equation. Okay, so these front 2 boxes, is there any other number? You always want to ask yourself, are there any other numbers I haven't used? No, I've got them all. So what does that mean I do with the 250x and the 780x minus 1? I just set them equal, huh? And that makes sense because this is a catch-up situation. The mom is running to catch up with the toddler. Catching up means equal distances, doesn't it? Like we said a while ago. Right? Whenever one starts later and catches up. At the moment of catching up, the distances are equal, aren't they? So that's what we do, set them equal. So there we go. Distribute 780x minus 780, 250x. Good like that. Distances are equal. How do we solve for x there? Yeah, minus the 780x. Gonzo. So what is that? Minus 530 equals minus 780. Is that going to be some ugly number? Divide by minus 530, divide by minus 530. So x equals, what is it? Oh, it wants a fraction? Oh, so it's 78 over 53, huh? Because it's 780 over 530. The two negatives cancel. And then you can just cancel the zeros. Divide by 10, in other words. So just 78 over 53. That's how they want that. Which is a weird way to say the answer. It's just, if you did a decimal, that's just over a minute. It's a minute and a half or something. Is that what it is? All right, we good there? Does that make sense? Getting the hang of these travel problems. So all these travel problems, you set up the dirt equation, you get the 4 boxes on the right, and the front 2 boxes by multiplying. Okay, questions before I leave that one? Right, good? Okay.
How many minutes is that, like 1 minute?
Yeah, if you divide it in your calculator, it's 1 point something. 1.47. So it's just under a minute and a half, just under 1.5, just under a minute and a half. All right. So an accountant rides a bus. Yeah, this one's a tricky one. Let me just dive right in and help you with this one. This is a tricky one. Okay, distance equals rate times time. So he rides a bus part way and he walks part way. So there's the bus and there's the walking. So the bus and the walking. All right. Let's take the facts as they come. The bus averages 40 miles an hour. Bus averages 40 miles an hour. What do you do with that? That's the bus rate. The accountant walks at 3 miles an hour. That's the walking rate, huh? Good so far? The distance from home to work is 21 miles. The total time for the trip is 3 hours. How far? Da da da. Okay, this one's different. This one's a little tricky. Let me show you. You understand what the accountant's doing? He's basically starting at home. He's like riding. Maybe he walks for a little ways, and then he does the bus for the rest of the way, and he arrives at work. So he walks and buses. Maybe he only walks a little ways. So he walks for a little distance, and then he buses for the rest of the distance. Does that make sense? He goes to make it from home to work. He walks a little ways, and he buses the rest of the way. So he walks a little ways, and he buses the rest of the way. To make the whole distance, the total trip is 21 miles. Right? That's the total distance from home to work. So that's not the walk distance nor the bus distance. It's the total, isn't it? So the 21 goes down here. It's not in either D box alone, is it? Everybody see that? It's the total distance. It's not the bus distance or the walk distance, right? And then the 3 hours over here, the 3 hours right here, that's the total time for the trip. 3 hours total time. So that goes down here also. That's not the time on the bus or the time walking, that's the total time. So it has to go at the bottom of the time also. So this one's weird because they're giving us a couple of totals and they're not giving us the individual. See how that's working? All right, so what does that mean then? What are we going to do? Normally, don't we normally go X and X like that? A lot of times we do that. Not always, but sometimes we do that. That's generally right, except I can't go X and X. I've got to go X and Y. Why? Why do I have to go X and Y? Because they're different, right? They're different times. How long he spent on the bus is a different time from how long he walked. I can't call them, if you make them the same letter, you're making them be the same. You're saying they are the same. And they're not. Now, we had a problem a few minutes ago where it said same time, right? Same time, so I made them both X. Remember that one? What was that one?
That's if you imagine.
Where was it? Number 1. Yeah, number 1. Question number 1 in this section, 7.5. See how it says, same time, right here. See, same time, so they were both just X. Because the truck and the car, same time. But that's not the case on this one. It's, we don't know that the bus time and the walking time are the same, so we got to use different letters. Okay, I've got 4 boxes. What do you do once you got 4 boxes? How do I get these front D boxes? Multiply, right? Remember, distance equals rate times time? So this will be 40 times X. 40X. 3 times Y. 3Y. Is that good? Isn't that how we always do it once we have 4 boxes? Multiply. Now, how many letters do I have?
2.
2. What does that mean I need?
2 equations.
2 equations. Here's your first one. Here's your second one. Those totals. Does that make sense? Let's write those out. So this one's a different one. I'm not going to put one this hard on the test. I'm going to put one like number 1, number 3, or number 4. There'll be one like those other ones. But this one is extra difficult. So there's that one. And then the second one, there's that one. That makes sense? So this one's extra hard. I'm not going to put one like this on the test. It'll be one of those other ones will be the test. The toddler or the trains or one of those. Okay, so there we go. There's our, how do you solve 2 equations with 2 letters? You guys are pros at this now, right? What do we got to do to solve 2 equations with 2 letters? Make those fronts opposites, huh? Make those fronts opposites. Make this bottom x a minus 40x. So it'll cancel the plus 40x. Getting the hang of that? Let's make those fronts right. Whenever we have 2 equations, we just make the fronts be opposites. And we can cancel them. So minus 40. Boom, boom, boom. So we get 40x plus 3y is 21. Minus 40x minus 40y minus 120. Add them up. X's cancel. This is minus something. Is it 99? Yeah. That's ugly.
See, when I get numbers like this, I'm not sure if I'm right or not.
I know it's concerning, isn't it?
Yes, when you don't have clean numbers,
You kind of assume you messed up, but we're right actually. Okay.
2.6.
Yeah, what is it? 2 point. Give me a little more accuracy.
2.675, so I would run 2.7.
Well, here's the problem. So we're good so far. We got that answer, 2.675?
Yeah.
Up here they say, remember, this is the key. It's not the answer. It's the key that will unlock the answer. Right? What do they want from me? What are they asking?
The walk.
How far? How far? What is that? Is that a distance rate or time question? How far? Distance. Distance. How far did the accountant walk? What is the distance of walking?
So yeah, this
Go
would,
to the distance walking box, which is right here. 3y. So they want 3y. So 3 times the 2.675. Somebody got that? What is that?
8.027 or 297.30.
8.027? Now you round. So don't round until the end. Well, don't round abruptly, I should say. Leave a few extra places like I did. Now they're saying round to the nearest tenth. That means one place, right? 8.0. Does that make sense? 8.0. Round to the nearest tenth. Round at the end. When they say round, wait to the end. Use some more decimals of accuracy until you get to your final answer, then round it. 8.0. The other question is going to ask how far he, what is it? This is walk? Walk. So the other one's going to be how far did he bus? We can do that by subtraction, right? Total trip is 21 miles. He walked 8. So if he walked 8, how far did he bus? Whatever 21 minus 8 is. 13?
13.
Must have bus 13. Make sense on that?
We need to do both.
Yeah, because you're right. So we got both. So we got the Y answer, and then I used that as a key to unlock the walking distance. How far walk? How far walk? Distance walking, 3y. Plugged into the 3y box, the 2.675 for y, got 8.0 rounded. So 8.0
And the bus.
is the walk distance.
And the bus.
And then to get the bus, I said total trip is 21 miles, so if he walked 8, subtract them. He must have bus 13. We good? So that's a hard one. I won't push you quite that hard on the test. There won't be one like that on the test. It'll be like one of those other ones. All right, how we doing? I have one more section I want to do. It's a quick and easy section. He's saying anything, I think. Yeah, that too. So, yeah. So, square root of 49. Remember what square roots? Yeah, you can use your calculator on everything. It's 7, right? That's all they want. These will be quick. This section you'll fly through. Square root of 49, 7. They'll put some x's in. I'll help with that. So, square root of 49 is 7. There's number 1. So, negative the square root of 4. Well, that negative just sits out there. He's not doing anything impressive. What's the square root of 4? Done. Just you got a negative in front. Now, in a second, they're going to put that negative inside the root. That's a different story. Just want to kind of preempt your thoughts. Negative's outside, who cares? He's just sitting there. He's just a spectator to the event. He's just watching, not on the field, right?
Plus or, if it's a negative, isn't it plus or minus?
No, we'll talk about it. So for now, it's just sitting outside. It's just a spectator. Like when I go watch my kids play some, I'm going to go watch soccer this afternoon. I'll just sit there. I won't be on the field kicking the ball away from all those little girls. I could do it, though. But that wouldn't be appropriate. So I'm just going to be watching, right? All right, so negative the square root of 225. So what is it? Yeah. Again, the negative is just a spectator. He's not in the action. He's not in the root. He's just watching, right? Playing in the game.
Error.
Square rooted. The negative got in the action. The negative is in the root now. Yeah, air. Calculator will say air. Why is it air? Yeah, why is it? Yeah, so it's not real. Is it a real number? No, is the answer. Why not? Why isn't the square root of negative 9 real? Why is our calculator telling us air? Yeah. Remember what square root mean? Like, what is the square root of, I don't know, like 25? It's 5. How would you explain it to a 10-year-old child? How would you explain why square root of 25 is 5? You know, right? You would say, yeah, multiply it by itself, huh? 5 times itself is 25. That's why the square root, right? That's totally correct. So use that same thinking to explain why the square root of 9 doesn't work. What times itself is negative 9? You can't have negative 3 times negative 3. That'd be positive 9, right? 2 negatives would be positive. You think, well, yeah, make 1 negative, 1 positive. Well, then that's not the same thing times itself. That's times the opposite. And we know square root asks same thing twice, right? See how there's no way you can have the same thing twice coming out negative? See how that's impossible? Because if you have two negatives, it's positive. If you have two positives, it's positive. And you can't have one negative, one positive, which is the only way you'd get negative 9, because that's not the same thing twice. That's why square root of any negative number is not real. Or error, says the calculator. Right? So it makes a big difference, doesn't it? Whether that negative gets in the action, in the root, or it's just a spectator sitting on the sidelines watching. Big difference, right? If the negative was just, if it was just negative, whoops, if it was just negative out there, no big deal. It'd be just negative 3, wouldn't it? He's just a spectator. But if he's in the root, that's an error. Can't do that. Makes a big difference. Okay, so negative the square root. They're asking, is that a real number? Is that one okay?
Yes.
Yeah, that one's fine, huh? Because the negative is just a spectator. He's just sitting on the sidelines. It's okay for the dad to just sit on the sidelines and watch. The coach doesn't want me to yell stuff out, though. So I'm supposed to, the coach is always, we've coached the girls, don't give them coaching from the sideline. So you can watch, but you can't get in on the action. So that's okay. That one's okay, but if the negative's in there as well. All right, so negative the root of negative 25. Did one of the dads get on the field?
Yes.
Yeah, the negative is in there. It's not good. Not good. Right? That's all we do. You cannot say those two negatives cancel. They don't. They're in different worlds. One's on the field, one's on the sideline. Different worlds. Can't do that. Much of this, they'll keep it pretty simple in this section. And we'll do more serious letters next week. All right, square root of a squared. What do you think?
A.
Yeah, a. Because remember what square roots do? They say what times itself is this thing? A times a is a squared. Yeah, it's just a. A is the answer. Plain A. All right, let's. Okay, so the square root of 4x squared, yes, it is 2x, because the square root of the 4 is the 2, and the x squared becomes plain x. So notice, you root the number, and you cut the power in half. Right, because it's a first power now? So you root the number, cut the power in half. Really good question. How about if this was square root of, let's go 9, let me do 9x to the 10th. What would that be? 3x to the 5th. Just square root the 9 is 3, cut the power in half. Yeah, if it was odd, like 9x to the 7th, yeah, it would be 3, but then you can't do the root of x to the 7th. We'll do something more fancy next week with them. For now, they won't give you an odd one, basically, is what they're going to do. Okay, so the square root of 37d squared. Now, this is a little tricky. This is not the same as that. That would be different. This answer is just 37d. Why? Because that 2 power is on everything. So what do you do with the 2 power? Cut it in half. It's a big old 1 power. In other words, it's just 37d. You see, whenever there's a power on something, whether it's an individual x or other letter, or on the whole thing, that power is cut in half. And whoever he's on comes out of the root with half the power. Does that make sense what happened there? I just cut it in half. They might not want parentheses. I'd be fine in a test, but they probably want it just straight like that. Yeah, so just cut the power. Okay, so how about that one? Square root of a squared minus 16a plus 64. Exactly. Do you realize you're going to have to factor first? Yeah, a and a. Remember how you what multiplies to be that and adds to be that. What times what multiplies to be 64? 8 times 8 is 64. How do you get minus 16 in the middle? Both minus, huh? If you lose 8 and lose 8, you lost 16. And then 2 negatives multiplied to be positive 64. Now, We good to there so far? Notice those are identical twins. That's the same thing twice. Now, what does a square root do to a 2 power? Chops it to a 1 power. In other words, it's just a minus 8. You see what happened there? See what roots do to a power? The root cancels the power, and the root's gone. The root is gone. The power has been halved. See how that works? That's what a root does. When the root does his job and cuts the power in half, he vanishes. Everybody good with that?
And then you get to like number 1.
First power, yeah, but we don't. First power, we just write it that way. That makes sense? Yeah, we don't show the first power. So again, when the root hits the 2 power, factoring. Boom, right there. Square root of 9a squared minus 6a plus 1. All right, so it's the same kind of thing. It's going to factor, it's the same thing twice. 3a, 3a. Remember how that works? 3a times 3a. Remember FOIL? F-O-I-L. Front times front. 3a times 3a makes 9a squared. And last times last to make 1. 1 times 1 makes 1. And they're both negative to make negative 6 in the middle. Remember the oi, the inner, outer, all that stuff. So then that's going to be 3a minus 1 squared. Then what does the root do to the 2?
3a minus 1.
Cancels it. Oops, I missed. And it's just 3a minus 1. So there's that section. So good. So we finished it. Let me do our usual clicker thing here.
It's over now.
So,
Oh, thanks.
all right. So what did we finish covering? We finished covering 7.4, 7.5, and 8.1. All of those. Gonna be on Monday. 7.4 and 7.5 are a lot more work. All 3 of those, though, are due on Monday. Our next exam's a couple weeks away. If you didn't get your old exam 4 or any other exam, they're all here.
What are we supposed to?
Oh, yeah. We should click.
Tell us what to click.
I thought I chose D this time. I'm kidding. A. It's just A. It's just A. A for apple. Click A for apple. A for apple. You're good. You got the 3 clicker points at the end. Check out your quiz grades. They're online. All the quizzes are in there. Well, except like the last couple. All the rest are in there. Your quiz grades, you go under results. You can get your grades on everything. Homework, quizzes, tests. It's all there. Check on that. Click on A. Have a good weekend.